Back in the Route Complete video course, we learned a lot about EIGRP. It used to be a Cisco proprietary protocol. Now it's open to other vendors. It's very scalable. It converges rapidly. We can do unequal cost load balancing with variance. It's got a lot of features. And in this video, we want to take a look at troubleshooting one of the more common EIGRP issues. And that is, we've got a couple of routers and they're not forming a neighborship. In our next video, we'll take a look at another common EIGRP issue. And that is, we're not routing appropriately. We're expecting a route to show up and it's not showing up. What's going on? But here, let's take a look at a couple of reasons that a neighborship might not form between a couple of EIGRP speaking routers. One reason is the interfaces at each end of this link interconnecting the routers are in different subnets. Now, this is an IP version 4 issue. Most of the issues we're going to be discussing apply to both IP version 4 and IP version 6, but with IP version 6, it's interesting. The interfaces at each end of a link, their global unicast addresses, they do not have to be in the same subnet, or they don't have to be part of the same network, because IPv6 uses link local addresses. But if we're talking about IP version 4, we need to make sure that the interface IP addresses at each end of this link are part of the same subnet. Something else that could be wrong, and this is an obvious one, but it's something to check, is the interface administratively shut down. Obviously, we're not going to be forming a neighborship over an interface that is administratively down, or maybe that interface is up, but it's not participating in the EIGRP process. Did we give an appropriate network statement, for IP version 4 anyway, to say that this interface is participating in this EIGRP process? Or with IP version 6, did we go into the interface and say that this interface is participating in this EIGRP routing process? Maybe we have an interface configured as passive. Now, remember what a passive interface does? A passive interface can still have its network advertised by the EIGRP routing process, but that passive interface is not going to be sending EIGRP messages. We're not going to form a neighborship over an interface that's operating in a passive mode. It might be appropriate to have an interface be passive if it's connecting out to a bunch of end stations. There's no other router out of this interface with which we're going to be wanting to form a neighborship. Sure, let's enable EIGRP for that interface so that that network gets advertised, but we might as well make it passive because we don't need to send or receive EIGRP messages on that interface. But we don't want an interface to be passive if we do need to establish an EIGRP neighborship over that interface. If we have authentication enabled, we need to make sure that we've got matching credentials on both sides. Maybe we're filtering EIGRP packets. We've got some sort of an access control list, and it's blocking EIGRP packets. That would prevent a neighborship from forming between a couple of routers. And something that's really critical with EIGRP is that the autonomous system numbers have to equal between neighbors. We don't want to go to one router and say, router EIGRP1, and then go to another router and say router EIGRP2, because those are different autonomous systems. They would not form a neighborship. Something else to watch out for is mismatched K values. Do you remember how the K values influence the metric calculation for EIGRP? By default, EIGRP only considers bandwidth and delay in its calculation, but we can make EIGRP consider other things. We can make it consider reliability and load through the manipulation of these K values, and K values must match between neighbors. Let's get some practice with our EIGRP troubleshooting now by going out to a live interface. In this topology, I've got all 4 of these routers configured as EIGRP speaking routers. However, things are not working as anticipated. I'm not forming any neighborships. Let's see if we can troubleshoot and resolve this. On router R1, let's take a look at our 3 EIGRP tables. I can do a show IP EIGRP topology. This can give me a list of networks known to EIGRP. And I do know about some networks, but these are all locally attached to this router. I don't think I've learned anything via EIGRP. I can do a show IP EIGRP neighbor to see any neighbors that I know about. And this does not look good. I don't have any neighbors, and we see that we're in autonomous system 1. I can also say, show me the interfaces participating in EIGRP. Show IP EIGRP interfaces, and it shows one. It shows that interface Fast Ethernet 0/1 is participating. Now, if you take a look at the topology, you see that I've got a network of 192.168.1.0/24 connected to Fast Ethernet 0/0. Is that interface not participating in EIGRP? Are we not going to be advertising that network? Well, not necessarily, because maybe that interface is set to passive. And that would be appropriate, wouldn't it? We don't have a router off of that interface with which we're trying to form a neighborship. It might be appropriate to say that that interface is a passive interface, but we can still advertise its network. Maybe that's the reason that interface is not showing up here. We can get some more insight by doing a show IP protocols command, and we can see that, yes, we are routing for that network, but I guess it was passive. And I'll let you peruse the output here for just a moment. And we're going to go over to router R2 and give some commands there as well. And let's see if we can determine why we're not establishing a neighborship between routers R1 and R2. You might want to pause the video to take a look at the output that we have here on screen. And remember some of the things we talked about a few moments ago that need to match up between routers for them to become neighbors. Let's go to router R2 and let's do a show IP EIGRP interfaces to see what interfaces are participating in EIGRP. Well, great news. It looks like all of my interfaces are participating. And I can see that I'm in Autonomous System 1. That matches up. That's good. Have I learned anything via EIGRP on R2? Let's look at the topology table. Have I learned? I don't really see anything that's not local to me that I've learned. All right. Do I know about any neighbors? No, I don't, which would explain why I haven't learned anything. Now let's do that show IP protocols command again. And again, you might want to pause the video, take a look at the output, and then hypothesize what might be going on. In fact, I'll toggle back and forth to make this easier. Here we have the output of show IP protocols on router R1. Again, you might want to pause and look at this. Here it is on R2. You might want to pause again. Do you notice anything that's not matching up that needs to match up in order for a neighborship to form? Well, we already said that we're using the same autonomous system number. It's autonomous system number 1, so that's good. But did you notice? The K values are just a little bit different. The K values, which can change how the metric is calculated, here on R1, the K values are 1, 0, 1, 0, 1. On R2, they're 1, 0, 1, 0, 0. The K5 value is different. Let's fix that. We might know off the top of our head that this is the default. K1 and K3 set to 1, everything else set to 0. Let's put R1 back to the default. Here's how we do that. Let's go into router configuration mode for EIGRP autonomous system number 1. And to change the K values, we're going to say metric weights. And the first value is a type of service value. That's a quality of service marking. It's going to be 0. Notice that only 0 is supported. We have to put a 0 there. Then we start putting in the weights. K1, we want to make it a 1. K2, we want to make it a 0. K3 is a 1. K4 is a 0. K5 is a 0. That should fix things for us. Now we've got equal weights. And by the way, the router console, if you're consoled into the router, it will tell you frequently that you have mismatched weights, mismatched K values between your routers. But to make it a little bit more challenging for us to troubleshoot, I turned off those console messages so that we wouldn't see that evidence popping up. But if you're consoled in, you would see that, not so much if you were telnet or secure shelled in, unless you did a terminal monitor. Let's see if we now have a neighborship. Let's do a show IP EIGRP neighbors. Great news. We are now a neighbor with router R2. I wonder if I've learned anything via EIGRP. Let's do a show IP EIGRP topology. And have I learned anything? Yeah, I sure have. I've learned about this 172.16 network. I'm not directly connected to that. I've learned that via EIGRP. I've learned that that's available out of this interface. In fact, if we want to see exactly what EIGRP learned routes have been injected into the IP routing table, we can do a show IP route and look for like this D right here. The D code indicates EIGRP. And we can see that EIGRP has an administrative distance of a 90. Here is the feasible distance to get there. By the way, a little reminder about feasible distance. Let's take a look at the topology table again. Remember that this number in our topology table, this is our feasible distance. This is the metric for us to get to this network. This next number is sometimes called the reported distance or the advertised distance. This is the distance, this is the metric that our neighbor is reporting to us. If our neighbor is R2, R2 is saying, here's the distance for me to get to this network. Well, it's going to cost us something to get from us to that neighbor. Once we add up the cost of us to get to the neighbor, we add that onto this advertised or this reported distance. That's what gives us this feasible distance. Well, we've got a neighborship with R2. That's great news, but I still didn't see a whole lot of routes as I was looking at my IP routing table. So let's go to R2 and see what neighbors does it know about. Show IP, EIGRP, neighbors. I've only formed a neighborship with R2, or with R1 instead. Let's see why we don't have a neighborship with R3. What about R4? Well, let's do that show IP protocols command again. Are we routing for that network that goes down to R3? Yes, we are. Let's go to R3 and see if we can figure out what might be going on. On R3, let's do a show IP EIGRP interfaces. That's a challenge. Look at that. Interface serial 1/0, which gets us up to R2, we're told that it's not participating. It's not participating in EIGRP. Well, could it be passive? Let's take a look. Let's do a show IP protocols. Am I at least routing for that network? It says that I'm routing for that network. Do you think that's what's going on? What would explain that paradox of the output saying, yes, we're routing for that network, but that interface is not participating? Let's do a show run pipe to section router EIGRP. Just curious if we have any sort of passive interface configuration. No, I don't see any passive It's not a passive interface, and I'm telling the interface right here to participate. So why isn't it? What do you think could be going wrong? Let's do a show IP interface brief. Is this interface up? Remember we said that an interface had to be administratively up, or obviously we're not going to be forming a neighborship. And we're in the up state. Take a moment and look at the output on screen and see if you can find something that might be preventing this neighborship from forming. Did you notice the IP address of this interface? It looks like I may have transposed the last two octets. According to our topology, the IP address for this interface should be 172.16.1.2, and now it's 2.1. I think we've got a wrong IP address. And if the IP addresses on the interfaces on each end of a link aren't in the same subnet, we're not going to form an EIGRP neighborship. Let's fix that. Let's go into interface serial 1/0, and we'll say IP address. Let's see, and the IP address should be 172.16.1.2, and we've got a 30-bit subnet mask. We should now be part of the same subnet. Oh, great. And we just got some confirmation on screen that we formed a neighborship. So let's take a look at show IP EIGRP neighbors. Ah, yes, there it is. And if I take a look at my interfaces, serial 1/0 is now participating. That's great news. But I still have an issue with R4. Neither R2 nor R3 has formed a neighborship with R4. What's going on there? Let's go to R4 and give some commands. Let's do a show IP EIGRP interfaces. Do I have interfaces participating in EIGRP? I do. All my interfaces are participating. Show IP EIGRP neighbors. Don't have any neighbors though. Show IP protocols. Notice it says I'm routing for this network, 0.0.0.0. Do I have an incorrect network statement? Now remember, the network statement, it's often misunderstood. The network statement is not saying advertise this network via EIGRP. The network statement is saying any interface that has an IP address that belongs to this scope of addresses defined by the network statement, make that interface participate in EIGRP. We're not saying advertise this network, we're saying any interface whose IP address belongs to this address space, make that interface participate. And if I want any or all of my interfaces to participate in EIGRP, a shortcut is to say network 0.0.0.0. And that's what we've done here, and that should be fine. But take a look at the output. And again, I'll go over to R3 and give a show IP protocols command. And you may want to pause and scroll back and forth in the video to see if you can spot any differences. And we'll be back in just a moment and see if we can figure out why router R4 is not playing nicely with R2 and R3. Did you notice that we've got something major that's mismatched between router R4 and everyone else? R4 is in Autonomous System 100. Everybody else is in Autonomous System 1. That would certainly do it, wouldn't it? Let's fix that. Let's go into global configuration, but let's get rid of that EIGRP process, and then we'll just add it back. With the correct autonomous system number, I'll say no, router EIGRP 100, and let's add back router EIGRP 1, and as a shortcut to make all of my interfaces participate, I'll say 0.0.0.0. And oh, great news. I formed two neighborships right then. Let's do a show IP EIGRP neighbors. Fantastic. Show IP route. Am I learning route? Oh yeah, I've learned several routes. Notice the decode. I've learned several routes via EIGRP. Great news. Now that was a look at IP version 4. Now, it's really similar for IP version 6, and you'll notice in the topology that I've got some IP version 6 addresses configured. Let's make sure we know how to look at the contents of these databases for IP version 6. It's very similar. We can say show IP v6 EIGRP interfaces, and we can see that on R4, I've got the interface going to R2 and the interface going to R3. They're participating. Show IP EIGRP topology. This can show me what IP version 6 routes that EIGRP knows about. And we can see what neighbors we have. And notice the neighbors are using the link local addresses. Basically the same set of issues. There was a difference. Remember that the IP addresses don't have to be part of the same network. The global unicast addresses don't have to be part of the same network when we're interconnecting a couple of routers. If we're running IP version 6, because as you see here, we're using link local addresses on that link to establish the neighborship. That's a look at some really common reasons why a neighborship might not be forming with EIGRP. And in our next video, we're going to take a look at another common EIGRP troubleshooting target, and that is some of my routes are not showing up. I'm not able to learn all of the networks that I think I should learn via EIGRP. We'll see you back for that in just a moment.